All right, so we're going to move on to notes for 2.1 B, I believe. No, it's 2.2A. We are going to talk about perpendicular lines in this set of video notes. However, what I want to do is, because I'm not there right now, if you need to, here's some answers for 2.1B, Day 1, Parallel Lines and Angle Relationships. I'm just going to let it sit here for a moment so you can pause and then copy answers down. Similarly, I've got like question 12 at the bottom, 13 and 14 at the top of the next page. Pause the video if you want to write things down. And then I also went through 21 through 23. You can pause and write the answers down. If you have any further questions, you can ask in class. So we're going to move on to these video notes. 2.2a, proof theorems about perpendicular lines. We are actually not going to prove anything. I'm just going to give you some theorems. We focused on parallel lines and angle pairs in the first section. So for this warm-up, it says, draw a horizontal line. Keep in mind that horizontal is left to right, like this. And draw a smiley face somewhere above the line. So if you draw a smiley face above the line, how would you calculate the shortest distance? So if I want the shortest distance from the line to the smiley face, it wouldn't be a diagonal either way. It would be a straight segment down. So the distance, the shortest distance between any line and another point is a perpendicular distance. Okay? So I want you to write perpendicular segment or even line is the shortest distance. We are going to focus on perpendicularity today. Angles formed with perpendicular lines. We're going to do some fill in the blank or highlighting. So we had this phrase of linear pairs of congruent angles. What we are going to do is look at it in terms of a theorem. It starts with the word if, halfway through is the word then. If two lines intersect to form a pair of congruent angles, then the lines are perpendicular. So if I have two lines and one intersects the other, and I have a pair of congruent angles, actually there's going to be 4 congruent angles, then the lines are perpendicular. So this will measure 90 degrees, this will measure 90 degrees, this will measure 90 degrees, and this will measure 90 degrees. You don't have to see the box, but if you have the word perpendicular, then you're going to have 90-degree angles. So the converse of that, so if we flip around the words and we start with if two lines are perpendicular, to start with, then the intersection forms, actually we're doing 4 right angles. I'm going to also show 4 right angles. So these two are very similar concepts. They're just the way that they're phrased are opposite. So if I highlight that, if two lines intersect to form a pair of congruent angles versus the intersection forms 4 right angles, then the lines are perpendicular versus we start off if 2 lines are perpendicular. So really all you need to know is if 2 lines intersect to form right angles, then those 2 lines are perpendicular. All right, example 1 down at the bottom. It says, explain how you know that angles have specific properties and the diagram angle 1 and angle 2 are congruent. So I'm going to kind of highlight that. Angle 1 and angle 2 are congruent. Explain why angle 2 and 3 are not supplementary. So in this particular problem, if angle 1 and angle 2 are congruent, and I know the idea of supplementary means it adds to 180, I know angle 1 and angle 2 are congruent. So it means that angle 1 and angle 2 are both right angles. According to our picture, I can see that the two lines of PS and VQ are intersecting. I am going to say explain why angle 2 and angle 3 are not supplementary. Because angle 2, I'm going to write the measure of angle 2 plus the measure of angle 3 cannot equal 180. Looking at my picture, I think that the measure of angle 3 is less than 90 degrees, and the measure of angle 2 has to be 90 degrees. So if the measure of angle 2 is 90 degrees, but the measure of angle 3 is smaller than 90 degrees, those two will not add up to 180. You can even see from the picture. Angle 2 and angle 3 are not going to make a linear pair. This won't be what you have in the homework. That's a little bit more higher order thinking, but hopefully you followed along with my demonstration. So let's go to the you try now. It says if C is perpendicular to D, and this is the information that we're given. The two lines are perpendicular. I'm going to draw a perpendicular box. That means this is 90 degrees, this is 90 degrees, this is 90 degrees, and this is 90 degrees. If two lines are perpendicular to each other, then you're going to form right angles at the intersection. Right angles measure 90 degrees. The question says, what do you know about the sum of the measure of angle 3 and angle 4? I want you to write the phrase sum of measure of angle 3 and measure of angle 4. So we're going to explain what we know, answering complete sentences. I am going to use math sentences though. I can look at my diagram. I labeled my diagram. I'm going to say the measure of angle 3 plus the measure of angle 4 is going to equal 180 degrees. Because I know 90 plus 90 is 180 degrees. And I know if two lines are perpendicular to each other, then according to this theorem up here, then the intersection forms 4 right angles. Okay, so I'm going to write the intersection of, the two lines, the intersection of line C and line D produce 4 right angles. Really what I'm looking at, it says, what do you know about the sum of the measure? So I really am only looking for this line right here. Okay, but I wanted to bring in the theorem as well. Okay, so the next part's a little confusing. It says determine which lines, if any, must be parallel in the diagram. And this theorem, I don't even know, it should have been brought up. I guess we didn't have it. There's another theorem that I'm going to write down after we get through this. Are the lines parallel? So if I look at X and Y, so I'm going to highlight and then unhighlight. So if I do X and Y, I am going to say yes, that they are parallel. And the reason is because X and Y are parallel, they are both perpendicular to line R. So I'm going to say that line X is perpendicular to line R, and I'm going to say that line Y is also perpendicular to line R. I'm going to highlight that and repeat it. So notice we are focused on this question over here to the left. Y, X and Y. That's X and Y. Notice how in the picture there is a box on X to R, and there is a box on Y to R. So both lines X and Y are perpendicular to the same line. That is actually a theorem, but I didn't have it written down, so I'm going to write it up on the top here. I'm going to write theorem. I think it comes up in the next set of notes. If two lines are perpendicular to the same line, then they are parallel, and I'm using the notation, to each other. So if I have my two lines that I'm starting with, line X and line Y, this one and this one, they are both perpendicular to line R given in the diagram. So because X and Y are perpendicular to R, they are parallel to each other. That is what you need to show in the box. X and Y are both perpendicular to the same line R. I know we're talking about perpendicular and parallel on the same line or in the same sentence, but that is a theorem. Okay, let's look at the next one down. Y and Z. I'm going to erase all of this. So Y and Z, I'm going to highlight those like in the purple again. Here's line Y and here's line Z. And it says, are they parallel to each other? They kind of look like they are, but I am going to say no because we don't have some of those boxes. Notice how I have a box here and I have a box here. Even though the picture might appear that you have parallel lines, line Z is perpendicular to S, and line Y is perpendicular to R. It's not the same perpendicular line that we have. I'm going to say line Z is perpendicular to S, and Y is perpendicular to R. These two right here are different. So therefore you cannot say that Y and Z are parallel to each other. And I'm going to keep erasing as I go through. So far we have just X and Y are parallel to each other. X and Z. Let's go back to like this. We have X and we have Z. Notice that they are both perpendicular to S. So what we can say here, just like the top one, yes, we can say X is perpendicular to S and Z is perpendicular to S. So because they're both perpendicular to line S, they are parallel to each other. And then lastly, I'm going to erase again. R and S, are they parallel to each other? Here's R and here's S. And yeah, I am going to say that they are parallel to each other because they are both perpendicular to line X. Yes, R is perpendicular to X and S is perpendicular to X. Because they are both perpendicular to line X, that means that they are going to be parallel to each other. All right, I'm going to go to number 4 for the You Try Now. and 5, and then I'm going to come back to 3. I think some of the kind of multiple choice problems are a little bit harder than doing the algebra. Here's the information. We need to find the value of x that makes segment AB or line AB perpendicular to line BC. We want these two to be perpendicular. If they are perpendicular, they are complementary, meaning making a 90-degree angle. So just like we did in section 2.1, x plus 8x plus 9 is equal to 90. So I'm going to have 9x plus 9 equals 90. Subtract 9 on both sides. 9x is going to equal 81. And then when I divide by 9, x will equal 9. If we look at number 5, same thing. I want this to be a right angle, therefore I want that to be 90 degrees. So to find the value of x, I'm going to just set it equal to 90 degrees. We're talking with perpendicularity, the number 90 degrees most of the time. Sometimes it involves supplementary. Versus parallel lines, we had an angle sum of 180 occasionally. And then for number 3, it says make a conclusion. Angle 1 and angle 2 are congruent supplementary angles. So they have to be supplementary, which means they would add to 180. Congruent means they have to be the same measure. So angle 1 and angle 2 have to be 2 right angles. 90 degrees, 90 degrees. What must be true? Angle 1 plus angle 2 together have to equal 90. Nope, but they have to equal 180. Angle 1 is 45 degrees. No, I already have in my diagram that it's 90 degrees. Angle 1 and angle 2 are a linear pair. That's not necessarily true. It doesn't say that they form. In this diagram, they are a linear pair, but they do not have to be a linear pair. You could have 2 angles, angle 1 and angle 2, like this. Here's angle 1 and angle 2. It does not say that they are adjacent. If it said the word adjacent, then part D would be true. I'm going to put not always. So that diagram, they're a linear pair. Here, not a linear pair. Angle 2 is a right angle. Yes, I like that as well. All right, so I think that's it for the notes. Please make sure you've got this all written down, and then you're going to start the homework, 2.2, and have that ready to be turned in.